Okay, so this is section 3 after break. So section 1 and 2, they were reflection test, refraction test. And if we do it in a more complex pattern using SASW, spectral analysis of surface waves, and MASW, multi-channel analysis of surface waves, we can, one advantage of this, it's the same source, receivers, but it's the way we analyze, but we'll have lots of geophones, ground surface, lots of analysis tools. And what we get is we can capture some of the limitations from reflection test and refraction test. So this SSW, MSW, some of the pictures I showed you earlier, those people hitting the ground, those are the setups for the SW and MSW. It's more sophisticated and more complex than traditional geophysical methods. It involves production and measurement of Rayleigh waves. They incorporate complex spectral analysis of Fourier spectra record at each geophones. So usually this is not done by hand. This is where the computers come. So a lot of data to analyze, to filter out data. And this method is subjective, so it requires a very seasoned expert to properly interpret data. It's not as simple as a simple reflection theory we saw, or a little better refractions, but the methodology remains the same, but the data analysis portion is more complex. So the two well-known accepted methods are spectral analysis of surface waves and multi-channel analysis of surface waves. So their advantage is it can develop complex soil stratigraphy, whether you have inclined layers, soft spots between hard layers, or like a voids. That kind of, say, complex geometry can be captured in MSW and SW tests. It can detect and see through soft soil layers. Unlike seismic refraction and reflection, that's a defect, and becoming increasingly more affordable to form. So nowadays, these are, almost every some geotechnical firms, they have like contractors, they have this equipment. So they go out in the way we do a lab test. You can have this, it's not too expensive, maybe $2,000, $3,000, maybe few geophones, 10, 20 geophones. And if you spend more, you can get more geophones, more analysis tools, more data. And it requires also training, the data processing. But it's becoming more increasingly affordable to perform. I'm not sure if Ethiopia has it. Probably they have. In some sites, they may have it, especially some critical projects to identify if there is sinkhole or like a mining kind of observations for oil explorations like that. They may have it at the government level. But I don't know if there is any university which has these equipments. Do you know of any? Maybe at Addis University? In the future, if we can, if there is badges from school or some kind of funding from PAN, Poly Alumni Network, or others, we may be able to buy these equipments, and so that you can use it within like a lab, just at least to have a feel of it or what it looks like. If you see some case study like 3D MSW characterization of sinkhole, a pilot study at USF Geology Park. This is Tampa, Florida in US. And this case study is freely available in the web. You can use this link and find it. But what they did is they have a geological cross-section of a sinkhole area. Tampa, Florida is very susceptible for sinkholes because of the limestone deposits. So ground stratigraphy looks like this. You see this is like a sinking or particles being washed away and some void is creating. And through time, if you do some kind of structure or building on it, this has a potential to collapse or even being sink. So MSW, more complex, lots of geophones in many lines, and then analyzing the data, There are softwares to plot it directly. You can spot this. What this paper describe is you have this from Joe, like, borehole testers or borehole, lab testers, and finding the stratification of the soil. And similarly, the 3D MSW is able to capture some of the spots for the sinkholes. You can see it here. You can go through this paper, how they did it, the setup, and the final model. Just to help you, it's freely available in the web, but it gives you how it is done. But generally, it's just trying to find what's underneath and trying to verify results, what's observed. Because if you do a borehole, that borehole is just giving you specific areas. You may miss sinkholes like this. But if you send waves like this, imagine now the simpler tier is the reflection and refraction. The refraction test, it can capture, client layers like this, but when there is sinkhole, it has limitations. The number of geophones that you require, the number of analysis that you require in the data, it's a lot. So that's why this MSW, SAW test come into picture. So, but finally, you can find, layer stratifications and also spots where you have cavities. So even without doing a boreholes, or if a borehole is missing it, you can model that. So I recommend you to go through this, especially this is a big application in geotechnical engineering. I mean, geotechnical engineering, it's applicable anywhere, whether you build a dam, whether they are doing a mining activity or oil activity, oil drilling activity, or building activity, there is always geotechnical engineers and civil engineers involved. The first thing they do is they ask you to investigate the site. And that's where this applies. These are the best techniques now to use because it's also getting much cheaper than drilling for boreholes and thousands of wells. This geophysical investigations, they are getting cheaper, but you need also verification. It's hard sometimes to truly believe this is the only way to get the inside information of the ground. So go through. I recommend you, it's not a homework or exercise, but just I recommend you to go through it and get more understanding of how it is done. So comparing surface wave meters, SSW, they have different applications. SSW doesn't work well in noisy environment. Lots of noise you may have to filter out, but there is a better section with MSW. This is the most widely used. That's why the case studies also with this method. It's good resolution even at higher depths. SSW is less complicated than MSW, where when things are more complicated, you get more realistic data. MSW works better in noisy environment. It has higher resolution at shallower depths and more difficult to perform and analyze than SSW. Now I understand we have limitation for this course. We don't have a lab or a facility to do these field tests, but this is a mini project for all of you. There are several mini projects in this chapter because this is very practical. It's getting the data. We are getting ready to model the soil, getting the input, and understand what is inside. So this is mini project 1. So what it says is any interested student or students can bring short presentation, preferably with video and pictures to class on SW or MSW field tests. So there is a lot of resource online. Go to Google, do your research, YouTube. There are many universities, the Western universities or Europe or Asian universities, which have a capability of doing these tests, and they already release those data for free online. So if you type in Google SSW or MSW test, you'll find a lot. So my goal here is, even if we have limitation in the school and are not able to do these tests, but you have a chance to learn more from those online. So just to look at it, it has a 10% weight for you guys, and maybe 1 or 2 of you can take this SSW, MSW test, do little research, bring information. And this is very practical. In the future, if there is a chance, this is very practical area. You never know where you will be. You'll be maybe going outside Ethiopia, maybe in US, Europe, or Asia. If somebody asks you if you are familiar with these tests, then it can be a living for you. So just think about it. How many of you would be interested? At least one or two of you. Last year I gave them only one student per this, but today, this time, you guys are around 12 students, I think, 10 or 12. So at least two of you can take mini project 2-1. So this is the second mini project, right? First mini project I gave you in chapter 4. That's preparing the seismic input, filtering and everything. So this is the second one. So we may have more mini projects. So maybe 50% of the course would be mini projects, right? So we'll go that way. So dig deeper, understand, and bring us some information. I don't have a lot of experience on this, but so I'm going to learn from you